So this is the correct one, although you have 1003 over there because that's one I was working on. Okay, so this chapter 6 on the bones. This is just the outline of the organization of the chapter. So first we're going to again take a look at the hyaline cartilage and how that helps to start to understanding bone formation. Then we're going to look at the several functions of the bones. And then you're going to start to classify the bones based on their shape. Then we're going to look at structures of the bones based on the classification of either compact or spongy bone. Then we are going to look at how the bones develop, and this is a part that I was really struggling on how to make sense out of this, okay? But hopefully we're gonna do a good job here. And then we're going to talk a little about bone remodeling, because that is very important for you to keep in mind that bone is really a live, active organ, right? The bones are very, very responsive to how much you use them. And keep in mind, even from now, that bone tissue is always being remodeled, and either you have a good constitution of bone. What is the noise I'm hearing? Am I hearing things? Okay, I thought there was like a little radio in the background. Maybe it's my head. So if you constantly practice exercises, like if you're constantly involved in sports and physically active, so your bones are going to have a certain density that is healthy, right? But also if bones have more mass and higher density, that means the bones are heavier. And that also means that your body has to put a lot more energy in maintaining those bigger bones. So your body in general is going to think that if you're not really using the bones, why should you maintain a big mass of bones? So it's based on the same type of philosophy like your muscles have. Like if you don't use them, you lose them. Right? So bone mass can be built relatively quickly within weeks or in a few months of exercise. But then if you become a couch potato for a couple of months, then you're going to lose your bone mass. You're going to lose a lot of that bone mass that you build, you work so hard to build. Okay, so keep in mind the bone is very dynamic. It's a very dynamic organ. Okay. So we are briefly going to touch on bone repair. But then this is really part of pathology, right? So we're not really going to focus on fractures, any of that. We're just going to have an overall idea of how bone gets repaired. And yes, we're going to talk some about remodeling of the bone. And just very, very superficially on the most known type of bone abnormalities and things that you often hear, I would say, in the media, or things that are quite common, like, for example, osteoporosis, right? We know that especially women, after the age of menopause, women start to lose some bone mass, and there is a reason for that, because basically hormones are going to dictate how your bones are going to be remodeled. Right? So here is straight from your book, why this matters. So you have a little video to watch. So this, at the end of this lecture, and then connected further videos that come after the lecture, right? You should be able to list the functions of the bone, right? To understand, remember what they are, and define some anatomical terms that are very often used with the bones, right? That they're defining the bone characteristic. And this is interesting. You should be able to compare spongy bone and compact bone. Know their differences. You know what is the unit of a compact bone, and then compare how is it that it can be really similar to spongy bones, and especially what are their purposes? What are the functions of these bones, right? Why is it the spongy bone is looking like that, and why is it the compact bone has those kind of straw-shaped structures? Okay. Then you absolutely have to be familiar with the types of cells that you find on the bones. Those are very, very, very interesting. And know what is it that the bone is doing in terms of responding to levels of hormones, and also how is it that, that the bone serves as a stock of mineral, especially of calcium in the body, right? And anatomical classes of bones. This, yeah, we're just going to work on a surface level here, because you're going to have a lot more of this in the lab, and I believe you already have seen bones in the lab, right? You've seen bones in the lab? You're working with bones in the lab? And I believe you're working with a cat? Yes, dissecting a cat? No? Not yet? Oh, good. Poor cat. I feel sorry for the cat. All right. So here, coming back to the skeletal cartilages, right? So we have looked at cartilage tissue before, and we're going to see it again when we get to joints, right? So basically, when the fetus, the embryo starts to develop and turns into a fetus, right, in uterus. Oh, I'm getting these messages here saying that the internet connection is low and is down. So yes, okay, I'm clicking 100 times. Be quiet. So when the fetus starts to develop, oh great, now kick me out of the class. Are you having problems with the internet? Like, oh, yeah. I don't know how this iClicker is going to work if this thing keeps on clicking me out. Okay, let me try to sign in again. So hopefully this thing is going to be working. Let's see. So when the fetus starts to develop, there are no bones in there, and there is basically nothing in there, because you have one cell that got fused, right? One egg cell got fused with the sperm, and then the cell starts to divide. And it's very interesting how the process of embryonic development takes place. And then when it comes to, I believe, week number 8 or so of pregnancy, this is when you start to develop this initial cartilage skeleton. Is not really bone, is not very solid, but is this mold or this type of a model of a cartilage that starts to develop at first. And the type of cartilage that does this, especially with the axial skeleton, is hyaline cartilage. Okay, so at that point, this cartilage, as we have seen with cartilaginous tissue, it does not have blood vessels, and also it doesn't have nerves, right? Which is a good thing for cartilage not to have nerves. Because imagine, if you're jogging and you have hyaline cartilage in your joints, if you're jogging and there are nerve endings in that cartilage, you're going to be feeling every step, and I guarantee you it's not going to be fun, right? So a lot of people, they're not going to be jogging or exercising if you actually have nerve endings in the cartilage, right? That would be quite painful. Okay. Now, surrounding the cartilage, you have a membrane, and that's called the perichondrium. Right? So this is a layer of dense connective tissue that basically keeps the boundary of that cartilage, or as a book puts it, it surrounds the cartilage like in a girdle. Okay? It keeps it in a place where it's supposed to be. So this membrane helps the cartilage to resist too much of outward expansion, because as we see, the way the cartilage grows, it can expand, go to the sides, right? So this membrane keeps the cartilage in a shape that is supposed to be. And also that membrane will carry the nutrients, will carry the blood vessels that are important to maintain the cartilage cells alive. Okay, keep that in mind, because it becomes very crucial after the cartilage, the hyaline cartilage, after it reaches a certain size. Then keep this in mind, that the cartilage cells are receiving the nutrients from diffusion, right? From diffusion that are coming from the supply that is in this perichondrium, right? Okay. Now, we know the cells that make up the cartilage, those are called chondrocytes, right? So those are cells that are sitting inside of those cartilage structures, and they are sitting inside little lakes. They are called lacuna. We have seen those before. You remember? Everybody remember? Everybody awake? Yeah, okay. Anyway, so here we go with the chondrocytes. Remember, those are the cells that are making up the cartilage. They live in this little lacuna, right? And they can divide, right? Hyaline cartilage especially. Those cells can divide, and they are going to be secreting those materials that will make the matrix of your cartilage. And then as they secrete, after they divide, they secrete the material, they drive away from each other, filling up the middle section with that matrix, right? So here we are basically looking at this hyaline cartilage, and you should remember where it is found, because we had that was also part of last test, right? And the basic functions of the hyaline cartilage is to provide support and flexibility and resilience, right? Now we find them after the fetus, after you are born, and in adults you find them mainly in articular joints and costal ribs, as you have the blue points here. And again, we have seen respiratory, nasal cartilage, right? And then we had also taken a look before at the elastic cartilage, and there was actually a question on your exam about elastic cartilage in the pin of the ear. I hope everybody got that one correct, right? Pin of the ear, okay. And then you have this other type of cartilage that is really, really tough, and this is the fiber cartilage. We have seen that before. Okay, now how is it that the cartilage is going to grow, right? So you have basically two types of cartilage growth. You have appositional growth, that is not oppositional, not against something. Okay, appositional growth means that it grows to the sides in layers, appositional type. And then you have interstitial growth. Okay, so this is when you have this chondrocytes that are inside the little lacuna, as I just described, and then they divide and they start moving apart and filling up the center area with that matrix, right? So this is type of interstitial growth inside the tissue in comparison to appositional growth, that this happens close to the membrane that is surrounding the cartilage. So those are cells very close to the perichondrium, that membrane, and the cells are growing, allowing the cartilage to grow in size, going in the longitudinal side, I would say. Okay. Now, cartilage sometimes can become calcified, right? And this can happen not only during development of bones, but it can also occur later on in certain situations. Okay. Again, cartilage that is calcified, that's not the same thing as a bone tissue. Okay, it's just calcified because minerals got deposited and hardened around the cartilage. So it doesn't mean that the cartilage became bone, it just got calcified. Okay, so here is your first question. And hopefully, our clicker, oh man, our clicker is not working. Yeah, internet is down. Okay, so this is what we are going to do. We are going to still just go through. So growth of cartilage from within the cartilage, not from close to the periphery, right? From within the cartilage is called what? What? Interstitial growth. That's your right answer. And again, now it's easy just because we just looked at it. But after you look at 200 other things, then you might not be as easy. So what you have to remember, within the cartilage is inside something. Interstitial is inside something. So that's your right thing. Okay. Okay. So functions of the bones. Some of them are very obvious and some of them not so obvious. Support, of course. Right? Oh, that's the thing. I was going to... Oh, and I forgot to record all this, so hopefully you remember it, because it's very obvious. Okay. Now, looking at the whole body, sets of bones, right? So you have a lot of bones. No, I'm not going to ask you to memorize them all. That would be a torture because I don't remember them all, just the most important ones, okay? So you have 206 bones in the body. That's a lot of bones. You have your axioskeleton. So that is what makes this center core here of your skeleton. And then the appendicular skeleton, that's your limbs, okay, and also your rib cage, and limbs, and attachment to the axioskeleton. So the axioskeleton is located alongside in the long axis of the body. So I have to close here. This eye clicker is just driving me insane. Okay. And it's not going to close. And close. Okay. And keep in mind that we're going to go back to the skeleton in the next chapter. So we're going to look a lot more into the functions of the skeleton. Okay, so here just the overall picture of your axioskeleton in blue and your appendicular skeleton in beige. Okay, so whole picture of your axioskeleton that is including your skull and spinal column, and also ribs and sternum. Okay, so this is mainly meant to support and protect your internal organs of both cavities of dorsal and ventral cavities. Okay, now this again, we can read it on your own, and you're coming back to the next chapter. And appendicular skeleton is very simple, limbs. Okay. All right, so now classification of bones based on their shapes. Okay, so we have long bones. Here is a picture of your long bone, and you have these bones that are very, they're of course longer than they are wide. And you're going to look at the specific characteristics of these bones, and then you have your short bones, right? And short bones, a subdivision of short bones includes the sesamoid bones. Now, those are bones that you're not born with. They develop after birth. We're going to also take a look at them when we get to the skeleton chapter. Then you have flat bones, and those are thin and slightly curved bones. And as you see here, it's they can make up the sternum. Most of the skull bones are flat bones, and also ribs, scapula. And then you have those irregular bones that they're so oddly shaped that we just call them irregular. So those are really complicated shapes, and typical bones are part of vertebra and hip bones, very strangely shaped. And this should be your second freebie question. The term long, short, or flat, or irregular, I used to classify the bones in order of what? Say is the shape. Yes. All right. So now we go to the bone. I'll put this in the updated one. So yeah. So you have it. The shape. I would go back, but I can't go back. Okay. So bone structure. Okay. Keep in mind, bones are organs. What is the definition of an organ again? Two or more tissues, two or more different tissues. That's the definition of an organ. Okay, so bones are organs because they're made up of different tissues. You have your osseous tissue, then you have nervous tissue, and a lot of it, okay? You have cartilage, connective tissue, muscle cells that are attaching to the bones, epithelial cells. You have all this stuff in this bone organ, okay? Now, basically you have three levels of the structure for the bones. So we have the gross anatomy, that's the stuff that you see and you touch and you can really see with the naked eye. You have microscopic structure, that's the part that gets a bit complicated. And you also have chemical structure of bones that is very, very important for functioning of the body. Okay. So here with the gross anatomy and brief gross anatomy of compact and spongy bone. So this one here is, keep in mind that the bones is not that they're going to have only compact or only spongy. They're going to be made up of a mix of those types of bones. Okay. So when you look at compact bone, you're going to see this very dense outside casting. See this outside layer. And usually this outside layer is going to appear very smooth and very solid. Okay, so that's this is an idea of your compact bone right there. Okay, so compact bone looks smooth and looks solid. So that would be like a shaft of a femur, for example. And then you have this spongy bone, and spongy bones are not soft. Okay, it's not like a sponge that you shower with. Right? They are named spongy bone because they resemble the structure of sponges, but they are actually very much solid. Okay, so it's not soft. Okay, so spongy bones have different structures that compared to compact bones, and they're made up of these honeycomb type of shapes. Everybody knows what a sponge looks like. Right? And those openings in these spongy bones, those are called trabecula. Okay, the little shapes that are forming the sponge bones are called trabecula. Okay. Now, inside the spongy bone, you're going to find the bone marrow. Okay, so when you look at the head of the femur, for example, you'll find red bone marrow, but then in other places you can find yellow bone marrow that is going to be found in this spongy bone, besides in the marrow cavity. Then you have your short and irregular and flat bones, okay? And those are going to be small and going to be consisted of sponge bone as well as hard bone. And let me see what's important to know here. Okay, the structure of these bones is that they are compact and they are really sandwiched between connective tissue membranes. Okay, so this is important to keep in mind. That's why I underline this. These bones are always sandwiched. They are always covered by a membrane. Okay, and then you're going to see how important the function of the membrane is for maintenance and also for repair of bone in case of problems. Okay. Now, when you look at the membranes that are covering up the bone, the one that goes on the outside of the bone, that is called the periosteum, and that makes sense because peri is for the periphery and osteum is for the bone, osseous tissue. So periosteum is the name of the membrane that is covering up the bone. And this is very dense connective tissue. Okay? Now, inside of the bone, you also have a membrane, but since it is inside, it's going to call endo something inside of the bone, and the bone has to be the last part of the name. So endosteum is the name of the membrane that is found inside, lining the inside of the bone. Okay. So the bone marrow is basically scattered throughout the spongy bone, is scattered throughout all these openings of the sponge bone, right? And in the bone marrow, you're going to find the cells, the stem cells that will give rise to all of your blood cells, and also to this bone cell that it's a bit strange and allows helps the bone to be dissolved. Okay, those are going to be your osteoclasts. So osteoclasts are coming from these bone marrow cells, okay, and they are cousins of blood cells, of macrophages. Okay, I'm going to see more on their structure and function of these cells. Okay. So again, you also have cartilage that is very important for covering some areas of the bone, especially areas that are part of movable joints, right? Because you don't want these bones to be hitting each other. You want to put a nice covering that is going to minimize the friction and put some cushion. Because remember how cartilage is made with all the water-loving matrix that is deposited in the cartilage matrix, right? And how flexible and shock absorbent cartilage has to be. So we go with flat bones, again, are consisted of spongy bone that is in the middle. Okay, so this is a piece of bone in your skull. So you see the spongy bone in the middle and sandwiched within layers of compact bones. Now, this is quite interesting because what is the function? Why do you have a spongy bone here in the middle of your skull bone? Why is that a good thing? It's kind of like a cushion, but this is it allows, for example, diffusion of force in case of impact, right? Because remember, the skull is going to be protecting this very delicate organ that is the brain, right? So here you see a hard bone on the outside, hard bone on the inside, and then this kind of cushion in the middle. Why not just have the whole thing as a hard bone? Don't you? Yeah, well, hard bone would actually would absorb shock, yeah, and would be kind of strong, as you see with the structure of the hard bone. It's strong. No, it would actually be hard to break it. It would, it would. You would distribute the force, yeah. Hmm? Blood cells wouldn't be there? Not sure about that. You could have a very thin layer of some spongy bone somewhere, or maybe have bone marrow somewhere else, you know. Yeah. Less weight. Yes, that's what I was waiting for, right? The hard bone, the compact bone, is very good at protection, but it's heavy. It's heavy. If we're going to have the whole skull made up of compact bone, it's going to weight a ton, right? It's going to be very heavy just to keep your head up in your neck, okay? It weighs a lot. So in order to not have a very heavy head due to bone mass, the inside of the bone can be made of this structure that can still absorb shock, but it's full of holes, so just to make it a lot lighter, right? Imagine if all your bones are going to be made of compact bones, it would be very difficult to move around, or the amount of muscle mass that you're going to need to move around is going to be a lot higher than is actually possible, okay? So here, when you look inside this spongy formation, we see these little things that look like coral reef. Those are called trabecula. That's the trabecula, the solid part, not the holes, okay? This is trabecula here. Okay. All right. So now we get to the fun part of these long bones, right? What do you see when you look at a long bone? You see two heads, you see the middle, right? So those have to have names. So the shaft of the bone right there you call your diaphysis. And yes, you have to remember that, diaphysis. The ends of the bones, those are called epiphysis, right? Epiphysis at the heads, diaphysis in the middle. Now, between the diaphysis and the epiphysis, there is this little layer that, in this case, this is a bone picture from an adult, so you don't see a little cartilaginous layer in there, but you should be able to see this line that is called the epiphyseal line, okay? Now, this line here, when this person was growing, this was actually called metaphysis. Okay, so metaphysis would be in the middle between your diaphysis and the epiphysis. So here it would be the metaphysis of a growing bone. Another name for metaphysis is epiphyseal plate. Okay, those are interchangeable. And this is only when you have growing bones. After you stop growing, that thing is called just an epiphyseal line. Okay. So here is your diaphysis. Those are going to be made up of this compact bone, and we're going to see the structures of what makes up this compact bone. And also the middle of the diaphysis is where you find the marrow cavity. Okay, so the medullary cavity or marrow cavity is in the middle of these long bones. Okay. So we look at these different parts. Okay. Okay, so here again, the tube of the bone or the shaft is called the diaphysis. The ends are the epiphysis. And so let's talk about the marrow that is inside right there, right? The marrow cavity. And then at the top of the bones, you're going to find these articular cartilages, and that's for joints. That's where the bones are going to meet other bones, and the cartilage is very important for shock absorption. And these cartilages at the joints, those are hyaline cartilages. Okay. So now looking more at details on what the bones look like, right? So the outside of this, in this case, actually would be close to a joint because this is articular cartilage. So I don't know where that piece of bone came from, right? So let's imagine this would be in contact with a different bone. Okay. Now, when you look at the compact bone, you are going to see these little structures that look like drinking straws put together, okay? So the outside here of your long bone, you're going to have this compact bone full of little drinking straws, but then more to the inside, you're going to have this spongy bone formation. So all the bones are basically going to have this type of architecture. Hard bone on the outside, spongy bone in the middle, okay? And keep in mind that the bone is very much alive and it has a lot of blood vessels. It has a lot of blood vessels that are supplying nutrients to the bones. Okay, it's not like cartilage that doesn't have blood vessels. So bones do have a lot of blood vessels. If you ever break a bone, they will bleed. Okay, a lot of time, but then sometimes you don't see bruises because of the membrane that is surrounding the bone. So you have bleeding inside of the bone, but not necessarily outside of the bone, outside of the membrane. But we're going to see more of that later. Okay. So here, looking at the membranes. Okay. So you have two types of the membranes. This is the bone, not the cartilage, right? So here you have periosteum. This is the very, very dense connective tissue, dense irregular connective tissue on the outside of your bone, right? So you have periosteum that covers the outside, but then the membrane that covers the inside, that's going to be the endosteum membrane. And it's not fair that it's not really showing here. It's just showing you the part of spongy bone. But imagine the same way you have this membrane out here, you have the membrane covering that part too, okay? So inside endosteum, outside is your periosteum. So if you look at the outside of the bone, like you're going to see in the lab, right? Well, when you look at bone in the lab, it looks dead because it is dead, right? Mm-hmm. So you're not going to see blood, you're not going to see a bone bleeding, right? It's just dead, right? But remember, bone is very, very much alive. There's a lot of stuff going on with the bones. So when you look at this membrane outside of the bone, that is a periosteum, it's not just sitting there with very little attachment. No, it has a lot of attachments to the bone itself, okay? So these attachments, they are going to secure the bone to the matrix of, secure the membrane to the matrix of the bone. So you have a lot, see these attachments showing right there? A lot of little attachments, and those are called Sharpey's fibers. So it's basically impossible or very, very difficult to peel out this periosteum away from the bone. Okay, you just can't do it. It's very, very solid. Okay. Now, inside the periosteum, you're going to find this osteogenic layer. Okay, so it's right there, just between this membrane and the bone itself. You're going to find the osteogenic layer. Okay, so osteogenic cells are cells that can differentiate to other cell types in the bone. Okay, so they can generate different bone cells, and they reside right there between the membrane and the bone. So that's where you find, just inside the periosteum, you find the osteogenic layer. Okay, so again, this periosteum has a lot of nerve fibers and a lot of blood vessels. And those blood vessels are very important because they help to bring nutrients to the inside of the bone. And mainly each long bone will have a very prominent opening that is called the nutrient foramen. Foramen is the opening of the bone, right? That you have this blood vessel that go to the outside to the inside of the bone. It goes through the nutrient foramen opening. Now, who believe me that the periosteum has a lot of nerve endings? Basically, if you ever broken a bone, does it hurt? Does it hurt a lot? It's very bad. Actually, bone pain is one of the most difficult type of pains to manage. You know, you can try to take any of these infamous painkillers out there, but it's not going to really work very well with the bones. Okay, so it's very difficult to treat bone pain. And you know, if you've broken a bone, you can't ignore it. Okay, and you also can't forget about painkillers because it's not going to work. You just have to tough it out, deal with it. Okay. Good thing about it is that bone tends to fix itself in most cases without needs of pins and stuff like that. All right. So the other membrane is your endosteum, right? So that's going to cover the surface, as we said. And that is going to cover all the trabecula of your spongy bone. So every little hole is covered by this endosteum membrane. Okay, everything is covered here. It's going to also line the canals that is going to pass through the compact bone. What canals? See those little holes over there? Those are called canals. All right, so endosteum is lining all of those little holes of your compact bone. Okay. Like your periosteum, just like the outside membrane, this endosteum also has osteogenic cells that can reshape or contribute to bone remodeling from the inside, especially here from the inside when you look at the spongy bone in the medullary canal. Okay. All right, so hematopoietic tissue in the bones, those are, that's where you're going to find your stem cells, hematopoietic stem cells. They're going to make the cells that make the composition of your blood. Okay, hemato is to do with the blood. So you have the red marrow that's found within the trabecular cavities of the spongy bone, and is also found within this diplo of the fat. Not the fat, the flat bones. Okay, so the center of hematopoiesis shifts from childhood to adulthood. In childhood, you can find it in the long bones, in the medullary canal, the long bones. But as you grow, by 20-something years old, then the center of hematopoiesis shifts from the long bones to the heads of the long bones and mainly to flat bones and irregular bones. So types of bone markings. So we're going to keep this really, really simple for this part of the class because I know we're going to be flooded with this in the lab. Okay. So what are the use for these bone markings? They serve as points of attachments for muscles, for ligaments, for tendons. Okay. They're going to attach to specific structures in the bones, and they also involve information of joints. And also it's very important for places where blood vessels can go through and also nerves can go through. Okay, so three major types of markings that we're going to mention, and you also have to know, are projections. Those are bulgings of the bone, and you can feel a projection if you just touch the behind of your head. Like right behind the ear, you find a piece of bone that is protruding a bit out of the skull. That's a projection. Okay. Depression, that is a concave type of shape in the bone. So it's like a very shallow cereal bowl looking from the outside. That's a depression. And then opening, obviously, that's a hole in the bone. Okay, so that's for passageway of blood vessels and nerves. Okay. So here are all of these terms that are very much identifiable with bones, and we are going to see more of this when we get to the skeleton. I just put this chart here because I thought it was handy and is in the book, in the chapter. Okay, and we're going to do a lot more of this when you get to the skeleton. Now, looking at the microscopic anatomy of the bone, you gotta know the types of cells that are involved in the bones, right? So there are five major types of cells, and yes, you have to know them. We have osteogenic cells. Now, osteogenic cells are going to give rise to osteoblasts and osteocytes, not osteoclasts. That's why that's like pushed all the way to the end, okay? So osteogenic cells can differentiate, and those are progenitor cells, and they can become baby bone cells. Those are the osteoblasts. And then these osteoblasts are really cool because they really understand that they are bone cells, so they start to deposit a lot of this bone matrix stuff around them, right? And then they become osteocytes. We're going to see how that works, okay? Now, you also have the bone lining cells, right? This is a type of similar to osteogenic cells. Those can be activated too. And then the fifth type is really these osteoclasts, and those are cousin of macrophages. Okay, osteoclasts are not coming from your osteoprogenic cells. Okay, osteogenic cells. Okay. So here, looking at the first type. So this is your osteogenic cell. Is also called osteoprogenitor cell. Same thing, right? Now they are active, they are dividing, and they are cells that are found just inside the periosteum and just inside that endosteum, right? So when they get activated, they are going to differentiate and they're going to become osteoblasts or bone lining cells. Okay, they're going to be laying down bone tissue. Now, of course, not all of them are going to differentiate, otherwise you're not going to have them anymore in the tissue. So when they divide, one of them becomes an osteoblast and the other one remains as osteoprogenic cells because they might be needed later on. Okay, so you don't want to just lose them dividing and differentiating when nothing would be left behind. So when they differentiate, they become osteoblasts. Those are bone-forming cells. Blast is for formation, like when you had the big blast of the world. It was Big Bang, or it starts with B, so that's formation, right? So osteoblast is bone-forming cell. Okay. What are they going to do? Well, they're going to secrete all this stuff for the bone matrix. Now remember, bone is connective tissue, right? You have more stuff than cells. So the stuff is secreted by the osteoblasts at first, okay? So what do you call the stuff? Stuff is called osteoid stuff. The stuff of the bones is osteoid stuff, okay? So what is the composition of this stuff, osteoid? Well, it's made up of fibers, you can imagine, collagen fibers, and is also made of these calcium binding proteins. That's what the cell is secreting, okay? And then you also have the inorganic part of the stuff, and mainly what you're going to find is calcium containing hydroxyapatite. You're going to see more on that. If you hear hydroxyapatite, you think bone, okay? All right. So the collagen makes up about 90% of the bone protein. It's not 90% of the whole bone, it's of the bone protein component of the bone, okay? All right. So those are, osteoblasts are dividing, okay? They are actively dividing because they have to make the bone tissue, okay? So here you can see a little transformation from this stem cell or osteoprogenitor cell that becomes this osteoblast cell. And you imagine, since this osteoblast is really producing a lot of protein that is dumping in the matrix, the endoplasmic reticulum and Golgi apparatus is very much visible and is very extensive in these cells. So then you have your osteocytes. Now, how are you going to get your osteocytes? Well, your osteoblasts, when they get so excited producing all this matrix and building up the bone tissue, right? So they are like producing matrix all around them, and they keep on producing this matrix, and then the mineralization and the calcification of the matrix is happening. And then it comes to a point where this poor guy, this osteoblast, finds itself stuck in a fortress that he had built, and he cannot get out because everything around it is calcified. So all the nutrients that he was getting at first, it's really not very abundant anymore because it built a wall around itself. So without that abundance of nutrients, it kind of gets quiet, and then it looks around and it has only this tiny little space that it can move, so it can't really move anywhere. So it starts to extend the tentacles and talk to the other cells that are in other little spaces, right, that they got themselves into. So at that point, the osteoblast is not an osteoblast anymore. It becomes an osteocyte. Okay, so the osteoblast, after it's done building this little lacuna that it sinks itself in, a little lake, then it transforms, it differentiates into an osteocyte. The osteocyte stays in the lacuna, only one osteocyte per lacuna. Okay, okay. So lacuna is one, lacunae with a e at the end, that's a lot of the lacuna. Okay. Okay. So what are these bone lining cells? Those are cells that are also thought to maintain the matrix along with the osteocytes, because once the osteocytes are in the lacuna, they're still going to be producing matrix stuff to maintain the bone structure. Okay. So if they are on the external surface of the bone, those are called periosteal cells, and then if they are in the internal surface associated with the internal membrane, that's endosteal cells. Okay, and then you have this fifth type of bone cell. Those are your osteoclasts. Okay, so those are going to dissolve the bone. So you have osteoblast building up the bone, osteoclast dissolving the bone. Okay. Now, those derive from hematopoietic cells, stem cells, that are in the myeloid lineage, and those become macrophages. The same cell line that becomes macrophage is the cell line that becomes osteoclasts. And they are very, very interesting alien-looking type of cells. Okay, we're going to look at them. Those are big, very big cells, huge. And they have a lot of nuclei, like average 6 nuclei, basically because they are made up of fusion of other cells that come together and make this huge cell. Okay, so this is called syncytium formation of cell. Okay. So they are very important for reabsorption of bone material, of dissolving the bone, and they are usually found on little depressions of the bone. So those are called resorptive bays. Okay, so this is where the bone is being dissolved. And those are the guys that are dissolving the bones. Okay. So here are the first 2 bone types, cell types that you see. This is your osteoblast, right? So osteoblast, when it finds itself stuck in a little lake, it becomes an osteocyte. Okay? It realizes it got itself trapped in a little space, so it develops these little tentacles or protrusions that allows communication with other cells that are stuck in other little places. Okay, so those cells are not very active, not as active as the osteoblast, but they are very important in maintaining the bone tissue around them. Okay, so this is from bone cell lineage, and this is the other guy from white blood cell lineage, and this is what your osteoclast looks like. Now, this side here of the osteoclast is different than the other side, because this is the side that's going to be attached to the bone, and it's going to make like this very tight attachment, like a little vacuum that gets stuck to the bone. Okay, and at the same time, this is important because it's going to seal off the site of bone demineralization, meaning that only the stuff that is going to be in contact with this area here that is going to be dissolved, and not just the whole bone everywhere. It's a very specialized type of dissolving the bone. And as you see here, there are several nuclei, usually around 6 or 7, that you find in this giant cell, And this is because several cells fused to make this giant cell. It's not like one cell divided nucleus into this many. No, it's like one cell got together with another cell and then another cell, and they all fused to make this giant blob. Okay. So anatomy, microscopic anatomy of your compact bone, right? So the compact bone is also called lamellar bone. That's just another name just to get you confused. Sorry. Okay. Not my fault. All right. So lamellar bone is also another name for compact bone. Now the unit of the compact bone is called the osteon. Okay. So that's really the basic functional unit of the osteon. Now inside of the osteon, you're going to have this canal, this central opening, okay, central canal, and that is called Haversian canal. Okay, you got to know that. Okay. Okay. Now the big canal in the center is the Haversian canal. And okay, so let's put it, let me use my new tool here. I got a new toy. Okay. Okay, so here you have the center canal, okay, of your osteon. This is your Haversian canal. Now around this canal, you're going to have little cells that are inside little lacuna. They go around like this. Imagine this is in 3D, right? So this lacuna, they're going to talk to each other through other tiny little canals. And those little canals are called canaliculi. I know it's kind of funny. And if you have any Italian background, the first thing that comes to your mind is funiculi, funicula. Any Italians in the class? No? One? You know the song? No? Oh my goodness. Okay, I'll put a link to the video just so you know what I'm talking about. Very typical fun tarantella type of song. Funiculi, funicula, you know, funiculi. Well, it just reminds canaliculi. Canaliculi is not the big thing in the middle. It's the tiny things on the side. Okay, tarantella dance around the circle, if it makes any sense. But you guys are Italian, so it doesn't make any sense. All right, so let's look more into this thing. What's going on here with this structure, right? So you have here your osteocytes, okay? Now the osteocytes are going to be arranged in a certain way that they're going to make a layer. Okay, see the osteocytes here? Now the layer that they make around here, that is called lamella. Okay, so that's the layer around this osteon here. That's the lamella. So if you look here, you have like ring here, lamella, ring there, lamella, ring here. The ring itself is the lamella. Got it? Okay. Now, lacuna, that's the little lake in which you find your osteocyte. This is a lacuna right there. Okay? This here going all around, that's lamella. This is lacuna. Don't get them confused. Okay? Lamella is layer, lacuna is a little lake. Okay. Canaliculi, those are all these tiny things that are connecting each one of your little lakes. So you have little canals connecting little lakes. Okay? Canaliculi connecting little lakes right there. Now, if you can imagine how these things are forming, so for example, let's say here you have your central canal. We are looking from a top view, right? So you have here osteoblast that is building up stuff around itself, right? And then it gets stuck, and this one is building up stuff. It gets stuck. This is a canal. This is just canal, okay? Canal blood. Now this one builds up stuff around it and gets stuck. So they started just like with this little game of ring around the rosy. Okay, so the ring around the rosy game, this what do you call this layer? That's your lamella, right? Now, because these guys get very isolated in the middle, they are going to start talking to each other via canaliculi. Okay, so know that is structure. That's the canaliculi. Okay. So how is it that this osteon is built? Okay, so osteons are also called Haversian system. Okay, so the osteon, you see your center opening right there. It has more of your big blood vessels, and you have your artery and vein, and what's that over there? Nerves. Remember, breaking a bone hurts. Got a lot of nerves in the bone, okay? So now, when you have this lamella, the way that the lamella is built, the way that the collagen fibers are layered on this tissue, they are very much at angles with the lamella of the next layer, with the next lamella, okay? So this distribution of angles makes the whole osteon more resistant to impact or to breakage. It makes the structure of the osteon very, very strong. Now you can imagine these fibers going this way. Those are, of course, your very strong collagen fibers. Now those are a bit flexible, but not too flexible. And then the stuff that goes in the middle, that's your calcified hydroxyapatite. And that is kind of brittle. It's strong, but it's brittle. So the analogy here, as I put down here, the analogy here is that the matrix of the bone is really concrete or cement that you can imagine if you're building a house, okay? But when you're going to build this house really strong, you cannot just build with cement, because if you try to, you put a hammer in the cement, it's going to crash, it's brittle. Now, in order to make it really strong, you can run steel bars along with the cement, with the structure. That is going to give it some flexibility and strength. And if you intercalate these different layers, you're going to have even a stronger type of structure. Okay, so the collagen is really your steel bars, and the matrix is really the cement that holds this structure together. Okay. Now these osteons, they are really parallel to the long side, to the diaphysis of your long bone. Okay, now let's picture this. If you have a bunch of straws, drinking straws, right, and you put it all together, all bunch of drinking straws together, and you put it on the table like this, right, if you try to crush them from the top, they're not going to break, okay, because the composition of this whole bunch of like strengthening numbers of straws, right? So each one of those osteons can be compared to a little straw. So try the experiment at home. Like you have drinking straw, put it together, try to crush from the top. It's not gonna bend. If you push it from the side, yeah, there is a little bit of lenience on pushing the straws from the side, right? But it's going to be a bit of a strong structure. Well, no wonder that if you crush a bone from the side, it's kind of going to break in a little bit, more frequently than if you use the same amount of pressure coming from the top. Okay, so the way that they are organized is really straws to bear the weight that's going to be on top of the bone. And that makes sense, because if you really think about your femur, like I'm standing, this poor femur has to deal with the weight of the rest of my body, especially if I'm walking. Imagine if I'm jogging, right? It's a lot of weight that this thing has to bear. So it makes sense that you have all these fibers that are aligned in this type of fashion to bear all this weight. They're going to go and be distributed and transferred from the hip to the bottom of the foot, right? So transfer of the weight is on these osteons. Okay. So here you have a side view of your osteons. Okay, so the central opening right there, that is your central canal, and then all these little communications that are going from one osteon to the next one. From one lacuna to the next one. You can't quite see here. Those are your canaliculi, right? Now, after looking here at the central canal, you have other perforating canals that go around them, okay? And they are important to bring nutrients from, or communicating from one canal to another. So those are what you call those perforating canals or parallel canals, also Volkmann's canals. So those are coming from the inside, from the center, from the medullary canal to each of those central haversian canals, and then communicating to other canals. Those are perforating canals. So bigger canals, tiny ones, those are the canaliculi connecting the little lacuna. Okay. I guess it is. Okay, so let me see what is important here. We mentioned that. So is it clear how you get to this structure that is the most important unit of solid bone formation? Do you understand how the osteon comes about? How it is made? Okay. So here, just keep in mind that when you have the formation of this bone tissue, at first you have the osteoblast that is forming, right, the bone tissue. And then when it builds, you can also have a better idea of what is happening to the osteoblast. For example, if you ever take the time to clean your kitchen, for example, right? So you're mopping the kitchen and you're like cleaning the kitchen this way, that way, and you start cleaning around yourself. Of course, you're not going to do that because you're very smart. But let's say if you're cleaning around and you go to the edges first, and then you clean a little bit more to the inside, and then you find yourself like you don't want to step in the part that is clean or you're going to get it dirty, and then you find yourself like kind of stuck in the middle, and it's like, what am I going to do now, right? I can't walk across the clean floor. So this is a kind of same thing that is happening to that osteoblast. It is building stuff around it, and then it builds so much around it, and it finds itself stuck. When it gets stuck, it doesn't have as much nutrients as it had before, just because it got itself stuck. So then it becomes that osteocyte that sits inside that little lacuna. So keep in mind how that is happening. Okay. So here's a whole picture of your compact bone. And also keep in mind that besides those lacuna that are found in these concentric rings, you also have other ones that are interstitial, that are in between the rings, and you have other ones that are surrounding the whole bone, like in the whole circumference of the bone. Okay? Okay, so this would be another question that we also going to get next time, I promise you. Group of concentric rings of bone matrix comprising the functional unit of long bones is called what? Functional unit of long bones, you have to think osteon. That should be your answer. All right. So then this other lamella here that we're talking about, interstitial and circumferential lamella. That's the one I was talking about. Okay, so the lamella that you have around the osteon, those are really composing the osteon, their haversian system. But then between osteons, you have other types of little lamella that you find that is not part of the circle. So if it is between the osteons, those are called interstitial lamella. The stuff that you're still going to find little lacuna in there, you're still going to find osteocytes in there, but it's not part of that ring, so it's just in the middle, interstitial in the middle. And then you have surrounding the whole bone, you're going to have this other lamella that is not part of the osteon and is not in the middle, so it's not interstitial. What do you call it? Oh, call it is in the surface, is on the circumference. So we call it circumferential lamella that goes around the whole bone, the whole thing. All right, so we're going to stop here.